Now in section 8.4, we'll learn about finding the circumference of a circle and the area of a circle. So just as a review, if I were to have a polygon, and let's say these are all different side lengths, if I were to find the perimeter of a polygon, I would add up all these sides. Or if I were to have an isosceles triangle, these two sides would be the same length. If I wanted the perimeter here, the perimeter would be 2 times the A side length plus the B side length. So with polygons, you add up the sides. We do not call the distance around a circle a perimeter. We call the distance around the circle a circumference. So it is a measurement. And here we have circle 1 that has diameter length D1. Here we have circle 2. By the way, all circles are similar because they're all the same shape. Here we have circle 2 that has diameter 2, and here we have circle 3 with diameter 3. And the interesting thing is that the ratio of the distance around circle 1 to diameter 1, so this distance to distance 1, and the distance around this circle to diameter 2, and the distance around this circle to diameter 3 is all equal to a constant. They all have the same proportion. And that constant actually happens to be a very well-known number. The ratio, again, which is a quotient, numerator to denominator, the ratio of the circumference to the length of the diameter is always a unique positive constant. So you have to have a positive constant, wouldn't be negative, and it is defined as pi. That is the Greek letter pi. Pi is the ratio between the circumference and the diameter of a circle. And pi is the ratio of the circumference of any circle to that circle's diameter. That is the constant. And so remember that the diameter is made up of 2 radii. If we were to have a circle, here, let's put a circle here. And if this is the center, if this is one radius and this is another radius, the 2 radii added together would make up a diameter. So a diameter is equal to 2 times a radius. And so the circumference of a circle is equal to pi times the diameter, or 2 pi r. Let's write that in a few different ways. You will not have to be proving this. I just want you to realize there are several ways to write these equalities. Circumference to diameter is equal to pi. All right, well, what if I multiply both sides of this equation by d? So let's multiply that side by d, which is fine as long as we multiply that side by d. So then we have the equation, the circumference is equal to pi times the diameter. And then if we remember that the diameter is 2 times the radius, we can replace diameter with the circumference is equal to pi times 2 times the radius. And just so you know, the standard way we write this, we'd put the constant up front. Circumference is equal to 2 times pi times r. All right, so pi is the constant. So it is a number, but what is its value? It's an irrational number. Irrational means it cannot be represented as a fraction with an integer numerator and an integer denominator. It also means when it's written as a decimal, it does not terminate and it does not repeat. nor does it repeat, I should say. So we just use pi. If you're asked for an exact value, if you're asked for an exact circumference, keep pi in your answer. However, if you are asked to estimate, there are a few different estimates. These are not exact values, these are estimates for pi. Pi is approximately the number 22 over 7. Not exactly, doesn't mean exactly. We can't represent pi as an integer in the numerator and denominator, but that's a pretty close approximation. To 2 decimal places, pi is approximately 3.14. Or if you were to use your calculator and just type in pi, every calculator should have a pi button, you'd get 3.1416 and maybe even some more digits, 3.14159. So if you're asked to estimate, often the question will tell you use 22 over 7, or they'll tell you use 3.14, or they'll tell you use your calculator's value for pi if they're asking for an estimate. But if they're asked for an exact value, keep pi in your answer. All right, so let's practice. Let's see what we see here. So here we have circle O. So the center is O, and we actually see this central angle AOB is a 90-degree angle, a right angle. We're told that the length of OA is 7 centimeters. Well, you know, that's a radius, which means the length of OB is also 7, by the way, because all radii are congruent. And notice they're telling us use the fraction 22 over 7 as the approximation. So they want us to find the approximate circumference of O. So circumference is equal to 2 pi r. So my circumference is going to equal 2, and we're going to use 22 over 7 as our approximation for pi, and my radius is 7. And on your calculator, or if you want to do it by hand, reducing the 7 in the numerator and the denominator, my circumference will be 2 times 22, or 44, and we look at our units. 44 centimeters. That's the circumference. That is the distance around the entire circle. And it is a linear measurement, and that's why it's just centimeters. Now, part B said to approximate the length of the minor arc. That was A. Now let's look at B. What is the length of this arc? Well, if this is a 90-degree angle, our arc has a central angle of 90 degrees. The whole circle has a central angle of 360. That's going to have the same ratio as the length of my minor arc to the length of the entire circumference. So keeping the units or my proportion set up properly, this is the small part of the circle, and this is the whole circle in the denominator. S-I-R-C-L-E. Central angle of 90, entire central angle 360 for a whole circle. Minor arc AB, entire distance around the whole circle 44. So if we want to find the measure of AB, this proportion holds, so we'll multiply both sides by 44. So let me go ahead and do that. If I multiply this side by 44, I'm going to multiply this side by 44. Do our reducing. And so if I have 44 times 90 divided by 360, you're going to find that you get 11. So arc AB. The length of arc AB, I'm sorry, not the measure, I don't want it in degrees, I want it in centimeters. The length of arc AB would be 11 centimeters.